Hey, welcome back. We're still getting a little intro to normal distributions, and we've got this empirical rule, the 68, 95, 99.7 rule that we went over at the bottom of page 22 of the statistics packet. How 68% of the data falls within one standard deviation of the mean, 95% is the number to remember for falling within two standard deviations of the mean, and 99.7% of the data falls within three standard deviations of the mean. This rule is nice because it's only really three numbers to keep track of, although we get more specific on the diagram. And the question is, when are you entitled to use it? You're entitled to use this rule whenever you see any of these three or four descriptions: normal, bell-shaped, or empirical rule, because it does apply to data that's normally distributed. Believe it or not, I said I like my grades to be skewed left so that I have a lot of grades on the high side, on the positive end. Some professors in college like to grade on a normal distribution. So you have most of your students landing in this mid, like most getting C's in that range, only a few getting high A's and only a few failing. And that's how they like to curve their tests and quizzes. All right, let's go back down. And can we talk for a second about the pleasant topic of the male European eel? So here goes nothing. What we want to do is, it says, does it say somewhere that the data is normally distributed? Well, it says sketch a normal curve. So that's what I want to do first. Please do not judge me on this artwork. The first step is to draw a straight line on which we can put our scale, and that was easy enough for me, but now the hard part. I want to sketch my most beautiful bell-shaped curve, and I hope that yours goes well, something like that, floating above it. I would like for you to label the mean right in the middle of this curve. So we're going to say the mean is going to be, for males, 15.7 inches. Can you do some labeling for me at 1, 2, and 3 standard deviations from the mean? So I want to know 1 standard deviation, 2, and 3, what the values are going to be, and 1 below, 2 below, 3 below. We're just going to label up this picture and talk for a second about it. So 1 above, feel free to use the calculator to help. You go 15.7 plus 2.8, you're going to be at 18.5, and if you subtract 2.8, you're down at 12.9. For 1 standard deviation above and below. Above, I want to keep labeling. So I want to add another standard deviation to that 18.5. So 18.5 plus another 2.8 gets you up to 21.3. That's your cutoff for 2 standard deviations above. I'll label the mean right in the middle. 2 standard deviations below, so 12.9 minus 2.8 gets you down to 10.1. Okay? And I'll even go 3 above and below like the problem says to. If I add 2.8 to 21.3, I get up to 24.1. And if I subtract 10.1 minus 2.8, I'm down to 7.3. That's all it really asks you to do. So you're pretty much done number 9 once you label it that way. I'll be able to handle the interpretation. Because this is a new question for us, can we put some percentages on this picture? So if 68% of the data falls within 1 standard deviation of the mean for normally distributed data, split that in half. Our other page says 34% lies here in this range, 34% lies above the mean. So from the mean to 1 above, the mean to 1 below. If I took 95%, because 95% falls between these two blue values here, and I subtract 68, right? What do I have? I'll do that quick. 95 minus 68, I get 27. If I cut that in half, that's 13.5% here. And then you start seeing these numbers come up a lot, 13.5% left over to be there. Now we've covered this whole 95%. Let's keep going outward. If I did the 99.7, which is your range for 3 standard deviations of data above and below the mean, so 99.7, all the way down to those green values, it should give you enough that if you do the calculation, it's 2.35 and it's 2.35 in that section. And like we said on the last page, there's not much left over. If you've already covered 99.7% of the data and you subtract that from 100, all you have left for those way outer tails are 0.15% at that high tail and then 0.15% at the low tail. That's all we're going to do with this. I could give you a follow-up question. I could say, quick, you did all that work labeling. What percent of eels are going to be in this range from 15.7 inches long to 21.3 inches long? Well, you'd be adding these two values. You'd tell me 34% plus 13.5%, right? and then give that to me as a percentage. That's going to be what, 47.5%? And you can say because the data is normally distributed, about 47.5% would fall between those two circled values. And that's what you'll see in the section, a series of questions in and around those. If I said what percent of the data is above the mean, that's a no-brainer. Don't take your time to add up all these numbers. Just say half the data is above the mean, 50%. And you can do the same thing for females, but I'll save that one for later. Lastly, I want to just look to the next page and end with this. Let's talk about people. So American males. Did you know that the average height of a guy is 69.5 inches? So I think that's 5'9.5". And the standard deviation, right? Standard deviation is going to be 2.5 inches. One last time, let's draw out a normal distribution. Let's draw that here. So your line goes first, and then you'll have your best bell-shaped curve right above it. So I have a line, and I've got a bell curve, and I want to label that up with lines, a mean right in the middle of 69.5 inches. I want to go 1 above, 2 above, 3 above, and then 1 standard deviation below, 2 and 3 standard deviations below. Feel free to add 2.5 a couple times and subtract it a couple times to get those values. I'm going to fill them in here. Feel free to pause if you want to get the numbers yourself and check them. I got 62 inches, 64.5, and then 67 on the low end. Above 69.5, adding 72, 74.5, and then 77 inches. So now it's adequately labeled, and you just have a couple questions underneath. We can put some percentages on here too. You might as well write them out to kind of get them into your head. The more you use these numbers, I think the more they sink in. So you've got your 34 and 34 for splitting that 68% in half. So 34%, 34%. Then I think the next two mathematically were 13.5, 13.5. Okay, the next numbers we found, just writing these out again, were 2.35 and 2.35. And then we got the 0.15 and the 0.15. It's worth it to list these if you're going to get asked a bunch of questions about the data. 11 says, here's an example, what percent of adult males are between 67 and 74.5, now that we've done all that work labeling. So 67 to 74.5. Let me add up this middle, these blue numbers, so the middle 68% plus the 13.5 that we also put below it. So plus 13.5, list our answer as a percent, and the approximation is going to be about 81.5%. Falls in that range. The reason we were allowed to do this is because we see that they're approximately normally distributed. That was the license to use this rule. In a group of 2,000, this is a great question, in a group of 2,000 adult American males, how many would you expect to be taller than 6 feet? Okay, so taller than 6 feet is on the high range, and we know 6 feet is 72 inches. We want to know how many fall in this upper range here. So what I'll do is, one way to do it is to add up those percentages. The 13.5% that we circled, plus 2.35 plus 0.15 to get a percentage. So the percentage should be 15.85% of males. Now that's not our final answer. They said we've got a group of 2,000 males. So let's figure out what is 15.85% of 2,000. So 2,000 times 0.1585 gives me about 317 guys in that group you can expect to be taller than 6 feet. Again, just approximations. If you said about 320, that would be okay as well. All right, it's been a pleasure. Hope the rest of your day is normally distributed. Speaking of the Eagles again, I heard we just drafted a wide receiver, so we'll see what happens with that. Enjoy your day.